Okay, so continuing on with chapter 7 and parabolas, 7.2 is just sort of a further detailed account of parabolas. So 7.2 is called properties of graphs of quadratic functions. And the first keep in mind bullet says a parabola, that is a graph of a quadratic function, is symmetric about a vertical line, which is called the axis of symmetry, through its vertex. So we talked about this in section 7.1, that parabolas are symmetrical. Let's go red here. Okay, so parabolas are symmetrical. Right through the middle, we have the axis of symmetry, which makes sense. And then what this is trying to show you, too bad I can't draw a straight line, hey? What this is trying to show you is that the distance from here is exactly the same as the distance from here. It's symmetric. So as long as you pick the dot that's perfectly horizontal to this other dot, they will be the same distance from that axis of symmetry. It's telling you the same thing there. Okay, so here's your axis of symmetry. Cut your parabola exactly in half, and then your vertex, which is either the highest or lowest point of your parabola, will always run through this axis of symmetry. Notice here, because the parabola opens up, they're telling you that this vertex is a minimum, whereas this one, when this parabola opens downwards, this vertex is a maximum. There's your axis of symmetry. Okay. If the function f of x, that's how you say this, it means the same as y, so don't let that intimidate you. It means the same as that. If the function ax squared plus bx plus c has an axis of symmetry that is defined by the equation x equals d, then these ordered pairs are the coordinates of the vertex. Okay? Don't worry about this yet. You probably don't know what that means, and don't worry about that yet. You will. Okay? But what they're telling you here is because the axis of symmetry goes through the x-axis, your vertex will have the same x part. So if this is going through at 3, where x is 3, then your vertex has to be at 3 something that you don't know yet. That's what that's saying to you. And then it says for the quadratic function ax squared plus bx plus c, the domain is all real numbers. Okay, so here I've massacred this parabola, but let's have a look. So remember that your parabolas can go on forever. All parabolas will have these little arrows on the end. This goes on forever. So it's saying that the domain can be anything. So as this parabola continues on into infinity, every single ordered pair that you can create that's on that parabola can be traced down to get its x coordinate. Every single one of them. Okay? So it means that this is going to continue on forever, and so is this, because every single ordered pair can be traced down to the x-axis, and it can be anything, because because this goes on forever. Okay, tracing down to the x-axis is going to go on forever, so it can be anything. Okay. Now it says when a is greater than 0, remember this first part of your parabola, when that's greater than 0 or positive, remember that the parabola is going to open upwards. And it says the y-coordinate of the vertex is the minimum value. Okay, so this is the absolute lowest point that this parabola will ever touch. Okay, that crosses your y-axis. Okay, so it says that the y-coordinate of the vertex is the minimum value of the function. Okay, so the x part of your vertex comes from the axis of symmetry. The y part of your vertex comes from the lowest point of that parabola. And this is just saying if it opens downwards, then this is the absolute maximum it could be. So the vertex will be an ordered pair, x, y. The x part comes from here, the y part comes from there. Okay, so let's give it a try. It says determine the y-intercepts, the x-intercepts, the equation of the axis of symmetry, the coordinates of the vertex, and the domain and range for this function. Negative x squared plus 2x plus 8. So the last lesson, I showed you how you can just use the online graphing calculator to graph them. But you will need to graph them by hand as well. So I want to show you how you're going to be able to do that. Okay? Don't worry about this f of x. It means the same thing as y. So it says, first of all, let's determine its y-intercept. So this is a big point, okay? When, I'm going to give you an example here. There's my x and y axis, and let's say that that's my parabola. It looks like this, okay? Right here is my y-intercept. Where does the graph cross the y-axis? And what you got to remember here is when it's crossing the y-axis, x is 0. It's got no other choice. When it's crossing the y-axis right here, x is 0. So to determine its y-intercept, all you do is substitute x is 0. It works that way every time. So if I go back to my equation, I'm going to have negative 0 squared, which is still 0, plus 2 times 0, because x is 0, plus 8. Well, anytime you multiply by 0, it just makes it 0 and it goes away. So your y-intercept is 8. And you know, when your equation is in the form of ax squared plus bx plus c, that last term, that c, is always your y-intercept because look, you're always substituting in x is 0. Okay, so when you go to graph your parabola, your y-intercept 6 is 8. So I know that for sure. Okay, it's not my vertex, it's my y-intercept. All right, generate points on the parabola. So when you calculate it, the fancy math way of saying that is generate points. So remember, we have the equation negative x squared, oh, I didn't need to put that in brackets, but whatever, plus 2x plus 8. So what we're going to do is take the x and plug it in. Negative 2 squared plus 2 times negative 2 plus 8. Negative 2 times negative 2 is 4, but that minus is sitting in front of it. So it's going to be negative 4. 2 times negative 2 is negative 4 plus 8. Well, negative 4 and negative 4 is negative 8. Plus 8 is 0. Okay, so when x is negative 2, y is 0. There's my ordered pair. Okay, you could do the whole thing again for negative 1. Okay, so when x is negative 1, I'm going to have negative 1 squared plus 2 times negative 1 plus 8. Negative 1 times negative 1 is 1, but it's negative. Plus negative 2 plus 8. Negative 1 and negative 2 are negative 3. Plus 8 is 5. Now, when x is negative 1, 3, 4, 5, y is 5. We just calculated that, okay? Oops, I went the wrong way. So I want you to pause, please. I want you to do the rest of your calculations and then press play and let's see if you're correct. I'm going to pause here too and finish up the calculations and then I'll see you back here in a second. All right, so if you've done your calculations correctly, this should be an 8. We already did that. We already substituted x is 0. When you substitute x is 1, you should have got 9. 2 should have given you 8. 3 could give you 5. Are you noticing a pattern? Look at here. 8 and 8, 5 and 5. Should have got 0 here, which matches with that. And then 5 gives negative 7. All right. So it says from the table, can you tell where the x-intercepts are? Well, remember when we were doing the y-intercept, x was 0. So if we're finding the x-intercept, we're looking where y is 0. Remember that f of x is the same as y. So here was my y-intercept. When you're crossing the y-axis, x is 0. There's my y-intercept. But when you're crossing the x-axis, y is 0. So here and here are my y-intercepts. Okay, so let's put that on our graph. So remember, negative 2 was 0, which is an x-intercept. You can tell right there. Negative 1 was 5. When x was 0, I had y was 8. When x is 1, I was up to 9. When x was 2, I had 8. Okay, look at how this is my highest point. When x was 3, I was at 5. When x was 4, I was down to 0. And when x was 5, it had to be -7. I don't even know if I have room. 3, 4. Oh, I just have room. Okay. So remember my equation was y equals -x². What happened to x squared? -x² plus 2x. It's on x. I was thinking about the 8 already. 2x plus 8. All right. Notice how my a is less than 0. It's -1. So doesn't it make sense that my parabola opens downwards? So parabolas aren't like lines. You can't get out a ruler. You have to freehand them. So you just have to do your best to, as smoothly as possible, line up your points. Okay, I'm not a good drawer at all, so this is about the best I could do. But what you got to remember is that parabolas are always symmetrical. I am going to get a line out of here. So have a look at the graph. Where is that axis of symmetry? And hopefully you realize it's right here. The axis of symmetry has to go through the vertex and it has to cut the parabola exactly in half. Okay, so there's my axis of symmetry. I'm going to change its color to red just so it's a little more visible. There we go. Okay, so this question, where is the axis of symmetry? Well, it's right here. We always label axis of symmetry. It's cutting your x-axis at 1. So x equals 1 is the equation of my axis of symmetry. Don't just put 1. It has to be an equation, and equations always have letters in that. So the axis of symmetry is x equals 1, okay? And then there's my vertex, okay? So vertex we label with the V, and it's at 1 because that's where it is on the x-axis, and it's at 9 for my y-axis. And remember, we would say that this vertex is a maximum because it's the highest point that this parabola will ever be. Okay, so right here at where y is 9 is the highest point it will be. Okay, and then the second question says, what is its domain and range? So domain is x, range is y. And so you say x is going to be the set of, and y is going to be the set of. It's that fancy E for saying is in the set of. All right, so x. And you know what? It's an easy answer for every single parabola because remember what I told you? This parabola is going to go on forever. So as it goes on forever, getting wider and wider, I can always go back up to my x-axis and trace it up. And even this point, I can trace it down to my x-axis. But because a parabola is a continual line, every single point is going to exist. So we show real numbers by putting this fancy double R. Now, why is the range? It can't be everything because this parabola doesn't go up and down forever, okay? It actually stops, remember, at 9. That's the highest that my parabola will ever be. But then it's everything below. So y is going to be in the set of all real numbers. However, the biggest y's ever going to be is 9. Okay, it's everything below it, every little point, including decimals and fractions and even negatives, but 9 is the absolute highest it can be. So what I wrote right here is y is less than or equal to 9. That's the highest. And then there's one other thing I wanted to show you because I'm done at this point. Remember how we graphed this point because we generated it on this table, but we didn't have one over here. So you could always plug in -3, and I can guarantee you, because this is like the center of my parabola, it's always symmetrical. It has to be, if you put in -3, you'd get -7 because I got that over here. But another thing you can do is you can just count squares. So if I went 1, 2, 3, 4 to get to my axis of symmetry, I can go 1, 2, 3, 4, and that's where that point would have matched up with. Okay, that point at -3 and -7. Okay, so sometimes when you generate a few points and then you know where your vertex is, you know where those other points are because you just go towards your axis of symmetry and count up to it and then count over. Okay, so practice drawing parabolas. It can't all be done with graphing technology. Okay, good luck.